All right, let's have a go at these scheduling problems. So this is the first example that they showed in the textbook. I'll show you how to do the algorithm to find out that 15 that goes here. So first thing you need to do is every single edge should have a double box, like the EST, LST box, plus one extra one for the finishing point. But where you want to draw them, you want to draw them at the beginning of every line. So where the C edge is, you want to draw your box here. And for the E edge, you want to draw it here, like at the beginning of every line. So we need a box for line A. So I'm going to draw it there, and then a box for line B as well. So I'm going to draw it there. I need one for D and one for F and one for C up here and for E, for G and for H. And then you also need an extra box at the finishing point. So an easy way to tell if you've drawn enough boxes is just to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to count your edges. 1, 2, 3, 4, 5, 6, 7, 8. So there should be one extra box than the number of lines that you've got. Don't count dummies because they don't really count as an edge. They're just an extended version of line C. Okay, so what you want to do to start is you always want to start all of your boxes at the beginning with zeros in the EST left-hand side of the box. So 0 here and 0 here. This one's for A, this one's for B. Now we're going to get to this box here, we can take any path possible to get there and then count how long it's going to take. So the only way I can get there is from box A up to box C. So I start at 0 and A takes 8 days. So C, EST is going to be 8. So 0 plus 8, 8 goes there. And then to get to this box for D, the only way I can get there is from the starting point down B. So start at 0 and then go 6 days on. So the earliest I can start job D is 6 days into the project. To get to here, the only way I can do that is to go from here straight across C. So I'm at 8 and I'm going to add 1 extra day. So now I'm at 9. So that's for job E. The earliest I can start job E is 9 days into the project. To get to this box here, I have 2 different options. I can either go 6 plus 2 makes 8, or I can go down here. Oh, sorry, I didn't actually include the arrow for that one. It was a down arrow. So I can go along here. So 6 plus 2 is 8, or I'm at here 9 and a dummy counts as 0, so it's going to be 9. When I do forward scanning, looking for my EST, I have to take the largest possible value. So I can get to this box two different ways, here and here. The largest one is going to be 9. So I put a 9 in that box. Then to get to this box here, there are 2 different ways that I can do that. I can go 9 and 3 makes 12, or I can go 9 and 1 makes 10. So I'm going to take the biggest one, which is 12. And then to get to this point here, I can only go one way. It's 12 and 2 makes 14. And then to get to my finishing box, I go 14 and 1 is 15. So that's your forward scanning done. You've found all of your earliest start times for each job and they're in the left-hand side of each box. And now we're going to do our backward scanning. So you always, whatever you put in that final box, you just copy it straight into the LST. So it's going to be 15 as well. Now remember, when we go backwards, we have to travel backwards on the edge that we are currently looking for. So if we're looking at box H, we have to travel backwards on H. It's easy in this situation because that's the only thing that we can do. So we're going to go 15, take away 1, makes 14. And then 14, take away 2, makes 12. Okay, if I want to find box F, I have to go from 12, backwards 1, that makes 11. If I want to get here, this is the box for edge E. So I'm going to go from 12, backwards 3, is 9. The reason why you can't come up this way to get to this box here is because this is box E. You have to travel on E, backwards on E to get there. You can't go this way because you're not actually traveling on edge E. You have to go this way. Okay, to get to here, I can go from 11 backwards 2. So that's going to be 9 in that spot. To get to here, I can travel 9 backwards 1, 8, or I can go 11 backwards 1, 10. That doesn't make any sense. We've got to go for the smallest one possible. So 9 backwards 1 is 8. So on your way back, go for the smallest number possible. And then the box for B, I'm at here 9, and I go backwards 6, I get 3. And for edge A, I'm at 8, and I go backwards 8, I get 0. So when you get at least 1 0 0 box at the beginning of your network, that's how you know you've done it correctly. If you don't have a 0 0 box anywhere at the beginning, at the start point, then that means you've made a mistake somewhere and you need to double check all of your working out. All right, let's have a go at another one. Oh, for starters, like I've already pointed it out in another video, but the critical path is 0 0 8 8 9 9 12 12 14 15. So it's A, C, E, G, H. So they're the jobs that can't be delayed without delaying the overall minimum completion time for the project, 15 days. And your float time for job B is 3. That's the difference between those two. The float time for D is 3. And the float time for job F is 2. And that's how long you can extend or delay those jobs B, D, or F without changing the overall completion time of the project. So let's flip this over and have a go at this one. This is the other example from the textbook. So first thing we need to do is draw our boxes. So I'm going to draw one here for A, draw one here for B, one here for C, and this is where it gets a little bit tricky. So this one I'm going to make belong to C. My line D starts here, so I'm going to squeeze one in down there. So this one will be for C, this one will be for D. E, one needs to go there, one here for F, and then one at the finish line. So we have A, B, C, D, E, F. So we have 6 lines and 1, 2, 3, 4, 5, 6, 7 boxes. So we know we've done it correctly. So we start our algorithm with zeros in our start boxes, and then we go from there. So to get to this point here, I can either go 0 and 6 makes 6, or I can go 0 and 9 makes 9. So I want to take the largest possible value in here, which is 9. Now the start point for D is the exact same start point for C, so they're going to match because it's the same way how I would get there. I'd go either 6 or I would go 9. So 9 there and 9 there. Now to get down here, I can either go, well, there's only one option. Well, there technically is 2 options, but they're exactly the same. So I can go 9 and 7 makes 16, or I can go 9 and 7 makes 16. So that one's going to be 16. And then to get to here, I can either go 9 and 8 makes 17. This 9 and 8 makes 17, or 16 and 10 makes 26. So the biggest number is going to be 26. And then 26 and 12 makes 38. So that's your final number. So it's going to take a minimum time of 38, whatever it is, minutes, hours, days, weeks, whatever your units are, to finish this overall project. So now I want to do my backward scanning. So I'm going to copy in the final number and then go from there. So 38 backwards 12 is going to be 26. If I want to find the box for E, I have to travel backwards on E. So I'm going to go from 26 backwards 10, so 16. To get to box D, I have to go backwards on D. So I have to go here backwards on D. So I'm going to go from 16 backwards 7 to get 9. And to get to here, I have to go backwards on C because this is the box for C. So I'm going to go from 26 backwards 8, which makes, what's that, 18? 18. And then to get to box B, I have to go backwards on B. So I have two options because at this point here, when I go backwards, I have two different options. I'm either going to go 18 backwards 9 or 9 backwards 9. And I want to take the smallest possible option. So it's either going to be 18 take 9 or 9 take 9. The smallest one is 9 take 9, which is 0. And then for here, I've got two options because there are two boxes at this point. I can go 18 take away 6 or I can go 9 take away 6. It's going to be the smallest option, which is 9 take away 6. So that one is 3. So your critical path are the boxes with matching numbers. So 0, 0, 9, 9, 16, 16, 26, 26, 38, 38. So our critical path is B, D, E, F. So those jobs cannot be delayed or extended without altering that 38, let's call it days, 38-day minimum completion time. We have a float time. A has a float time of 3. C has a float time of 9. And those are the only two jobs that can be extended or delayed without delaying the 38 days. So we could push back the start of job A to 3 days into the project, and we're still going to get the whole project done in 38 days. Or job C, we could push it back by 9 days and still have the overall project finished in 38 days. Or we could take 9 extra days to complete job C and you wouldn't run into any problems. Okay, let's try one last one that I've made up. Let's have a look. Okay, we've got this one here. It's a little bit more complicated and we've got 3 boxes to begin with. So let's start by drawing our boxes. So I'm going to draw one for A, one for B, and one for C. So this is going to be A, B, and C. Okay, I need a box for F. I need a box here for I. I need a box, let me draw it down this way, for E. And here for G. I just find it easier if it's like along the edge. That way I know this belongs to E and that one belongs to G. It's how I visualize it. You might find that helpful. That one's for D. This one is for H. And this one is for J. And one for my finishing box over there. So let's just make sure. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges. So I should have 11 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we're good to go. So zeros in all of your starting boxes. And let's go ahead. Right, let's go to these boxes first. So I'm going to go from 0, 0 or 0, doesn't matter, along B line of 2. So the quickest I can get to these 2 spots is just 2. And that one's also going to be a 2 because they're both at the same point. Okay, to get to here, I can start at 0 and go along 4. So that's going to be a 4. And then to get up here, I have 2 different options. I can either travel up this way or I can go through B and up. So I'm going to take the biggest possible value. So I'm either going to go 0 and 3 makes 3, or I'm going to go 2 and 0 makes 2. So the biggest option is 3. I'm going to put that one there. Okay, to get over here, I only have one way of doing so. So that's to go from 3 and 4 makes 7. And then to get down here, I have 3 different options technically, although 2 of them are the same. So I have 4 and 2 makes 6, or I have 2 and 5 makes 7, or this 2 and 5 makes 7. They are both the exact same thing. So 4 and 2 makes 6, or 2 and 5 makes 7. So the biggest one is going to be 7 for that spot there. Okay, and then to get to here, I have 4 different options. So I either go down here, I use this box along here, this box along here, or this up that way. So let's find out which one's the biggest one. So 7 and 3 makes 10, or 2 and 6 makes 8, 2 and 6 makes 8, or 7 and 4 makes 11. So the biggest one is going to be 7 and 4 makes 11. And then to finish off, I've got 11 and 5 makes 16. Okay, we've completed our forward scanning. We now want to do our backward scanning. So copy in the same number. So this whole project is going to take us 16, let's call it days, 16 days to finish off. And now to find box J, the LST for J, we need to travel backwards on J. So start at 16, go backwards 5, we get 11. To get box H, we need to travel backwards on H. So we're going to go 11, backwards 3 is going to be 8. Like, couldn't remember how to do 11 take away 3 for a second there. Yes, 8. Okay. If I want to find box I, I've got to go backwards this way. So 11 take away 4 is 7. And then to get box G, I have to go backwards on G. So 11 take away 6 is going to be 5. To get box E, I have to go backwards on E. So I've got 7 take away 5 is 2. To get box F, I have to go backwards on F. So 7 take away 2 is 5. To get box D, I have to go backwards on D. So 8 take away 4 is 4. All right. And then to get box, where are we? Here. This is box C. So it's going to be 5 take away 4 is 1. To get box A, I have to go backwards on A. So I've got only one option. It's 4 take away 3 is 1. And then to get box B, I've got a couple of different options. So I can go 5 take away 2 is 3. Or I can go 2 take away 2 is 0. Or I could do 4 take away 2 is 2, because this one is an extenuation of job B and it comes down this way. Just make sure you're traveling backwards on that dummy, because dummy is pointing upwards. You want to travel backwards on the dummy and then backwards on B. So the smallest one out of those, so 4 take away 2, 5 take away 2, or 2 take away 2 is going to be 2 take away 2. So that's 0, which is good because we get a 0, 0 in that spot. We need at least 1, 0, 0 for it to make sense. So that means that we haven't made a mistake, I don't think. And we can find our critical paths. So we've got job B, job E, job I, and job J. So B, E, I, J, that's our critical path. We cannot change the times of those jobs. Otherwise, we would change the 16-day minimum completion time of our project. Some float times. We've got job D with a float time of 1. So job D can be extended by 1 hour or delayed by 1 hour. Job H is the same, can be extended or delayed by an hour. Job G could be delayed or extended by 3 hours. Job A and C both have a float time of 1, so does job F, 4 and 5, and I think that covers all of them. Okay, so let me know if you have any questions about this. It's a complicated process when you start learning it, but after a while it gets easier. Just make sure you've got the right amount of boxes, that they're always at the start of each edge. When you're moving forwards, you take the largest value. When you're moving backwards, you take the smallest value.